Hi, welcome to the shop. Today I'm working on optimizing feeds and speeds on the Tormach PCNC 1100. I'm working with 3/8 thick 6061 T6 aluminum extrusion and making parts for my glassworking machine, the NQALHA. When drilling holes, it's really important to keep the drill bit clean. I've been working on different feeds and speeds and peck cycles to try to keep the chips off of the drill bit, and as you can see, the drill bit came out nice and clean. Now we're reaming the hole. This is a precision hole that's going to accept a pressed-in bronze bushing. My first reamer didn't do quite as good a job. It was a grizzly, and even if with plenty of cooling and the proper feeds and speeds, it seemed to build up a little, kind of like a galled bit of aluminum on one tooth and produced a rough cut. Well, then I got some good reamers. The hole is beautiful. As I'm continuing to learn how the machine works and what are the proper feeds and speeds, I'm discovering that a faster feed and a slower speed produces a thicker, shorter chip that doesn't get clogged in the tool. This half-inch hole is being drilled at 1500 RPM with a 50 thousandths peck and 10 inches per minute. The tool stays perfectly clean. What isn't visible in the video is the spindle horsepower meter that shows this is using about as much horsepower as the Tormach has available. And the drill bit comes out perfectly clean. This countersink really likes to be slow, 400 RPM or else it chatters. Now we're going to do a tapped hole. This will be an 832 tapped hole, also using a more aggressive feed on the smaller drill bit, but a higher RPM. When I first started doing tapping on the Tormach, I was pleasantly surprised that, wow, it seems to work. And then I started breaking taps. And I trace this down to sometimes I get lucky and the chips clear away from the tap. I'm using a spiral tap, a spiral tap. Now there, I'm applying some tap magic. And it really is magic. But in the past, when I had problems, I was letting the machine run unattended, and it would do 10 or 20 holes in a row, and then I'd have bad luck, and the chips wouldn't clear properly. Notice that there's still some chips on the tap. The chips wouldn't clear properly, and uh-oh, broke a tap. Now here's something new. I'm starting to experiment with higher speed milling operations. This is going at 5,140 RPM, which is the maximum RPM the machine can do, and a 40-inch per minute feed rate with about a 975 depth of cut. So it takes 4 passes to get through the 3/8 material. Spindle horsepower is still reasonable, and I think I can push it a little bit more. Now the finishing pass, slowing down to 3,000 RPM. For some reason, even doing a very light 15,000ths cut at high speed, the machine wants to chatter. I'm not sure I understand. Moving to the other vise, for the second operation on a tooling plate, going to use the same parameters, cutting rapidly, 4 passes. When I first got the machine, I attempted to cut all the way through in one pass at 5,140 RPM and 10 inches per minute. Well, the poor little Tormach just doesn't have enough horsepower, and it stalled out. As I was experimenting to try to figure out what to do, I tried slower feed rates, I tried slower speeds. I ran into a lot of combinations where the tool started chattering like crazy. In the last video, I kind of settled on 3,000 RPM and a few 7 or so inches per minute, doing the entire depth in one pass. This produced quite a buildup of chips, and I figured there's got to be a way to do it better. This approach seems to be a good approach. It's still not at the limit of the spindle horsepower, and I'm going to start experimenting. I think I can probably knock it up to 50 inches per minute and maybe do it in 3 passes. I'm also looking at using the Lakeshore Carbide special aluminum roughing bit to see if I can get some more performance. But learning is fun. Now we're doing the finish pass. 3,000 RPM, 20 inches per minute. Makes a really nice surface finish. Throughout this entire operation, haven't had any chatter. I think I'm making progress. Also, early in my exploration of the Tormach TTS tooling system, I was having some tool pull-out. After adjusting the power drawbar and adjusting feeds and speeds, there is no tool pullout. And now, there's our part.